The power of a power property deals with exponents. And we're really talking about what happens if we have something like this, where I get an exponent that's already raised to a power, and now we raise that whole thing to a power. So the power of a power. Well, let's kind of look at what this looks like from its simplest standpoint. Kind of break it all the way down, and then we'll look at what the real property says. So here's what this really says if we start off with the very basics is x to the third raised to the fifth means that I have 5 of these objects. Okay? So what that means is I have really this. X to the third. I have 2 of those. I have 3 of those. I have 4 of those. I have 5 of those. So I've got 5 of those x cubes. 5 of those items. And what does that really mean? Well, let's kind of look at the next step here, which is if we were to kind of break this down even more. Well, x cubed really means this. That I've got x times x times x, x times x times x, and we've got 5 of those. So I've got 5 of those pieces in there. That now what I'm looking at is how many x's do I have altogether? So if I was to count those, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. I have 15 of those x's. Okay, that's if we want to really kind of break this down, look at all the little pieces of what this really says. But now what does the property really say? Well, the property says if I was going to do this problem, so if it was to say maybe simplify x cubed to the fifth, okay, well here's what the property says. Property says I could take these two numbers and I can just multiply them. Just multiply those together and I'll get my solution. So when I do this problem, x cubed raised to the fifth, property says that's the same as taking x to the 3 times 5. Well, what's 3 times 5? 15. Same solution as we got when we did this long version here, but now we're getting in a much quicker, cleaner version. Rather than counting each one, we can just multiply it out. Okay, let's go one more just so we make sure we get this correct. So simplify. And again, the problem might say something like x to the third raised to the ninth. Now, I would not want to write out x cubed times x cubed times x cubed 9 times. That's going to take a lot of work. So I fall back on this property that says, okay, rather than doing that, just take the 3, multiply it by the 9, and 3 times 9 gives me 27. And so I know how many x's there are very quickly.